Okay, so we're going to try this again. Let's see if this works. Okay, so this is the sheet that we're starting on. We're going to work on this together today. This is the one that was posted on Classroom. I don't know if I posted it on your Classroom. Anyways, I posted it on Virtual Classroom last night. But we're going to be trying to predict bonding. We're still working on bonding. After all this time, we're still talking about ionic and covalent. Okay, so we're going to start though, and we're going to work through this worksheet together, and we're going to try to get almost all of the first page done today. If you already know what you're doing on this page, feel free to work ahead. That's fine with me, okay? If you would like a little bit of help, we're just going to work through a few at a time, and I'm going to spot check as we go to make sure we're all doing it right, okay? So here we go. What we're going to start with is we're going to try to predict bonding. So that's number one, predict bonding for the following based on the types of elements involved. So it gives you these choices. It gives you like Li and Cl. So you got Li and Cl. If you were going to try to bond those or predict the kind of bond that would occur, but you didn't have electronegativity values and you didn't have characteristics, what would you base it on? Maybe electrons. What else? And what? Sorry. Yes, where they're at on the periodic table. Good. Like, and basically, are they a metal or a non-metal? Right? So you know where lithium is on the periodic table, right? And you will need a periodic table if you can't see one close to you. Lithium is way over here, like in the group 1 metals. Chloride is way over here in the halogens, okay? So lithium is a metal. Chloride is a non-metal. So what kind of bonding would you predict? Ionic or covalent? Ionic, very good. So I would predict that this would be ionic. So right there on number 1, you could just say, I would predict this would be ionic. And just so we're all on the same page, for ionic things, we know ionic things typically tend to be a metal with a non-metal. Okay, for covalent things, what are those typically? What kinds of elements? Non-metal, non-metal, good. Non-metal, non-metal. And then, of course, metallic would be metal, metal. Good. All right. So look at the next one then. You've got K and O. Look at where they are on the chart. That's what you're going to need to look at. Ask yourself, is it a metal with a non-metal, or are they both non-metals? Okay, and that's what you're going to need to decide. If it's a metal with a non-metal, it's going to be ionic. So go ahead and try to work through all of number 1. So that's A through F. I just want you to classify them based on the kinds of elements that are there, okay? Yeah, and on this, I mean, you don't even have to do that, but yeah, that's going to ask you to do that. But yeah, I mean,
So
you can
is this
combine
one
them.
just like, you just draw it out?
Yeah, this one you would just draw those dots and that's it.
Okay.
This one, you're gonna have to show bonding. If you want to combine the two, I don't care. But when you get down to this one, it also says sometimes you may have to draw extra outs. So like on this one, now how many bands like on this option there? Group 16.
Oh.
So 16
Oh,
minus
this is
10.
all.
So
Those are
yeah,
handy
that one,
thing.
yeah, I know.
Let's do that.
That one's missing a group.
Yeah.
So, yeah. Okay. Yeah, it's just, sometimes it takes a while to find them.
Yeah.
All right. Okay. All right. So keep working. If you haven't finished A through F, just keep classifying. On number 2, we're going to go ahead and look at some of the ones on number 2. Number 2 says, okay, now support your choices on number 1 with electronegativity difference values. Classify A through F as either ionic, polar covalent, or non-polar covalent. You'll need the Pauling scale of electronegativities on this part. So the Pauling scale, and I'm going to present my screen. Let's see if I can get this to work. Share. The Pauling scale is listed. It's on Classroom, and it was also part of the notes from yesterday if you were here. But it's this thing. It's the electronegativity values. You need this. Every element, with the exception of most of the noble gases, have an electronegativity value assigned to them, right? It tells you how strongly they'll attract electrons if they're bonded with something, okay? And they go up. The electronegativity values increase as you get closer to fluorine. So what you're going to do, like for instance, for Li and Cl, you would look up their values for the Pauling scale. Okay, so I'm going to freeze that. So you would look up their values and see. Okay, and so for Li, you would simply write down, so this is number 2, by the way. For Li, it has an electronegativity value of, is it 0.98? Yeah, what's Cl? 3.16. Okay, and with those values, then you just subtract them and do big number minus little number. You don't want negatives here. Just do big number minus little number. So you'll do 3.16 minus 0.98. Did anybody do that math already? Yes, Sebastian, what'd you get? 2.18. Yeah, so 2.18. So at that point, you've got the difference, right? If you remember from yesterday, we talked about a scale. There was a scale that ranked them from like non-polar covalent all the way up through ionic, okay? And in the notes from yesterday, let's see if I can find that. On the notes from yesterday, the scale looked like this. And we wrote it in our notes. Oops. Okay. So 2.18, where would that fall? Would that fall as being pure covalent or non-polar, polar covalent, or ionic? What would it be? Ionic, right? Because that's above, it's well above 1.8. So 2.18 would make this be ionic. So did we support what we said? Yes. We predicted it would be ionic based on what it was. And we proved it with electronegativity values. Okay. So this is what you're going to be doing on number 2. Okay. So you need to find their values, find their electronegativity values based on the Pauling scale. Okay, and again, that's on Google Classroom if you want to find the big one. And then see if you can get done with A through F. See if you can predict the type of bonding based on their differences. How's it going? Yeah, that's good. Good. Oh yeah, KNO. Oh, so it's definitely ionic, right? For sure. Oh, well, in this one though, aluminum is a metal, bromine is a non-metal.
Oh, like this.
So yeah, bromine is. Do you need a periodic table? I have an extra.
Yeah, I don't know what around.
Yeah, cheers. Okay. Yeah, do you want to get that? Thank you, Kenyon.
I love how you walked right by the door.
Oh, sorry.
Focus. You need to pull that out. Just this right here.
okay.
The funny before.
Okay, thank you. Do I send it back up to the office?
I'm not sure. She didn't say.
Okay, all right, thanks. Oh, okay, yeah, that's fine. All right, so for the next one, letter B, all you're gonna do is find K and O and write them their values. So like K is gonna be I can't see that, 0.82. Yeah, so, and then O is 3.44, and you subtract them. Okay, once you subtract them, you're gonna look at this little scale that we wrote down yesterday. Really thick paper. And then wherever it falls, like within the scale, like if it's over 1.8, you're gonna say it's ionic. If it falls between this range, it's chlorocovalent, and then less than that, it's just gonna be non-chlorocovalent. But you gotta find the difference first on each one, and you gotta subtract. Yeah, this one is all jacked up, and we're gonna look at this one, and that's good, I mean, you did it right, and that's fine. I'm gonna give you an easy way out.
Okay.
But that is fine, that's the right idea. Good. Yep, and that's good, that's good. And well, actually, you just need O2, and I'll show you why here in a minute. Yeah, but, I mean, you got the right idea, you're just finding those symbols. What do you think, Phil? It is a little bit. What on this one? AL is right here. This AL and O and O. It's another way. You know what's right there? It's a non-O. So metals and non-O. I know it. And then O, it's just an O bonding with an O. So a non-metal with a non-O. So anyway, yeah. I mean, if you want to use that thing, I can see that. But I think I'm gonna give you that one. Okay. Okay, they're coming right along. All right, and keep working. We're trying to get a little sampling of all of them. So we're looking at number 3 now. Number 3 says, for A through F, draw Lewis dot diagrams for each atom. Okay, so if we're looking at letter A says that we've got Li and Cl again. And we want to come up with Lewis dot diagrams for each one of these. And if you remember, we said yesterday that a Lewis dot diagram shows the outermost electrons, okay? And the way that you tell how many electrons to draw, how many outermost electrons to draw is you look at their group number. So Li is in group 1, so you're going to use 1 valence electron. Li will have 1 valence electron. We're going to represent those with just dots. So Li would have 1 dot on it. That represents its outermost electron. Okay. Cl is over here in group 17. So Cl is right there in group 17. See the group number listed? And the way that you do these over here, like in groups 13 through 18, is you take the group number minus 10 to get your valence electrons, okay? So group number minus 10, so the group number for it's group 17, and then minus 10 would be 7 valence electrons. Here's how I would like for you to draw these on. Okay, we're going to do a round robin. You're going to start on some side. I don't care where you start on the CL, but you'll go 1, 2, 3, 4, 5, 6, 7. If you will draw these like this to where you do a round robin, it will help you figure out how many single available bonding electrons you have. Okay, so like this chlorine right here, how many available bonding electrons does it really have? 1. It's the single right here, single ready to mingle, right? So, but knowing that this is ionic, there's a way that we're going to show this kind of bonding. We're going to show that this electron is going to be given, it's going to be transferred to the chlorine. This one only has 1 electron it's got to get rid of, so I'm going to transfer it. And I'm going to do that showing that this is an arrow. I'm going to show that that electron is transferred. It's going to the chlorine. That's how you're going to show your ionic drawings on these. It's not going to be the same as what we're going to do for covalent. So with the ionics, you need to show transfer. Now, if you're already good at drawing these diagrams, I was telling Katie just a second ago, number 3 is really just drawing the Lewis dot diagrams. Just drawing the dots. Number 4, you're going to have to do this step. Now, if you want to keep it as 2 separate problems, if you want to draw your Lewis dots on number 4 and then or number 3, and then on number 4, do this again and draw the bonding, you can, or you can combine it all on step 3. It's up to you. Okay. But otherwise, on step 3 or on question 3, you'll just draw Lewis dots. That's all that you would do. Okay. So for instance, on K and O, everybody look at the chart and find potassium K. See what group it's in? It's in group 1. How many valence electrons would you show? How many dots? 1. Good. 1 dot. Everybody find O. Find oxygen. It's in group 16. It's right there somewhere. Okay. So 16, how many dots would you draw? 6. Yeah, 6. And remember, round robin. 1, 2, 3, 4, 5, 6. And you'll notice on this oxygen how many bonding electrons are available. There's 2. There's 2 single bonding electrons available. Later on, when you get to number 4, you may have to draw another potassium in order to make this work. Okay, but just for now, on number 3, if you want to just draw the dots, I'll come around and check them. Yeah, very good. That's it. Yeah, they both go on. Right. Yeah. You know how to do this. Okay, good. Let me touch like that all good. Okay. And while we're here, so like on the K and the O, you have to draw an extra K in order to account for those two single electrons. Let me ask you this. So if K got rid of this electron, if you get rid of something negative, what happens to you? You become positive, right? So it would be a positive charge on this and on this K, right? And if oxygen picked up 2 electrons, what happened to it then? If it gained 2 extra negative charges? It has a -2 charge. All right? So there's your +2, there's your -2. So because they're charged now, they're going to be attracted like magnets, and they're going to go together to form an ionic compound. What would the formula, the chemical formula, be to represent this ionic compound? What's the ratio of potassium to oxygen? 2 to 1, right? Potassium is 2, oxygen is 1. And the way that we represent a formula like that is we'll simply write K2O1, but the 1 is understood. So that's the formula for potassium oxide. Okay. What would the formula be here for Li becomes positive, chloride becomes negative? How would you write that formula? LiCl, very good. Okay, now while we're here, let's go ahead and look at the next one, the C and the N. So letter C, it's carbon and nitrogen. So carbon and nitrogen. This one gets a little weird. So if you're trying to do number 3 and number 4 at the same time, we're going to do this together. Now, if you've already done it and you figured out the formula, kudos, because it's a pain. That formula is a pain. So I'm going to give you an easy way out. Okay. All right. So for letter C, you have carbon and you have nitrogen, right? So how many dots, how many Lewis dots should I draw on carbon, everybody? You can't see it, but they're all going. All right. So 1, 2, 3, 4. How about nitrogen? 5. 1, broke my own rule. 2, 3, 4, 5. Okay, now let me ask you this. How many bonding spots does carbon have when it's written like this? 4. It's got 4 bonding spots. How many does nitrogen have? 3. That's unfortunate, isn't it? Okay, but also let me ask you this. So what kind of bonding will this be between carbon and nitrogen? What type of bond? It's, well, and it's covalent. Like, is it ionic or covalent? It's covalent because it's a nonmetal with a nonmetal. Okay, and specifically, if you look at the difference, is it polar covalent or nonpolar? And what was it? Polar covalent, okay? Because it landed between like 0.4 and 1.8, right? Was it 0.49 or something like that? Yeah. Okay, so this is polar covalent, which means there's going to be a pull to one side. One of these atoms is more electronegative, and it was the nitrogen. So nitrogen is going to pull on these bonds. So here's what you got to do. Since this is covalent, we're not going to draw arrows. You don't draw arrows here. You simply connect the dots. So this is single and this is single. So I'm going to connect these 2 singles and these 2 singles and these 2 singles. And now we're left with that rando, which sucks. Okay, you could continue to add another nitrogen, but then you'd have to add another carbon. And then another nitrogen. And it goes on like that for a little while. What formula did you end up with, Katie?
3 and 4.
Oh, C3 and 4. Good. So both of you did it. Yeah. It takes a while. The other thing you could do, if you want an easy way out, you could just stick a hydrogen on here. Right? Now, technically, I didn't tell you could do that. But I'm telling you now, if you want to just stick a hydrogen on here, how many valence dots does hydrogen have? How many? Yeah. Just 1 valence electron. So if you wanted to just bond that, because usually in nature, that's how that is anyway. This is called hydrogen cyanide gas. This is the gas that they used in World War II in the gas chambers. They would take potassium cyanide pellets, like salt pellets. They would pour hydrochloric acid over it, and this gas would be created. So this is really a thing. HCN is hydrogen cyanide gas. But also this Lewis structure is a lot easier to draw if you just stick hydrogen on there. Okay, but either way would work though. Like you just know that you've got to be bonding all of those single electrons. Okay, so the formula for this then would just be HCN. HCN. Okay. All right, so continue to work on the next few structures. Try to come up with Lewis dots and come up with the drawings for those on number 3 and 4. How's it going? So this one, yeah. So you got bromine, right? And bromine's got, and how many should bromine have? Well, that one's missed in a group though.
I couldn't find it.
Yeah, this one's missing group 18, so it's technically group 17. Yeah.
So if you do it now.
Yeah. There you go. So each bromine will have 7. You can connect that one. So then how would you fix these two? Could you add more bromines? Yeah, for sure. That's what I would do. All right. So continue to work on that. Here's what we did in the morning classes. Like we did not get past, like we were struggling to get through number 4. Okay. So I think what I'm going to do tomorrow is as part of your lesson for Wednesday, because you will have a science assignment tomorrow. I'm going to post a video for you to watch to get your steps to draw Lewis structures. You'll write that down, and then you can go ahead and try to draw the Lewis structures for number 6. Okay. And then we'll come back and we'll talk about this on Thursday, and we'll finish this out. Okay. All right. So keep working. Try to get that done. Try to get at least 1 through 4 done. If you're just dying to find out Lewis structure rules, you can go ahead and look those up. So